I think we can go to the poster presentations, because in our minor body session, we've got a few posters. And the first one will be presented by Paweł Koleńczuk from Adam Mickiewicz University. Paweł, are you with us? Yes, I see Paweł. Okay, you can start to share the screen and present.
Okay, for a minute, I share my screen.
Okay.
Do you see my screen?
Not yet.
Okay, and now?
There is info that you started to share the screen, but we don't see the screen yet. At least I don't see. Okay, now it is visible.
Okay. So hello everyone. I would like to present our preliminary result of our observation of superfast rotating near-Earth asteroid 2022 AB. This object was discovered on 2nd of January, and it passed the Earth at a distance of 9.6 lunar distance on the 20th of January. And what distinguishes this object is the very favorable geometry of observation during this close-up. The phase angle was changing in the quite wide range, like you can see here, and observation of the asteroid at such a wide range of the phase angle, and in particular of the position effect, allow for the accurate determination of the phase curve and the absolute magnitude. Our campaign started on the 4th of January, and until 26th, we observed this object using small telescope located in many places around the world. And we collect a very large amount of useful data, but due to the fact that we have just finished our observation campaign, we are at the stage of preliminary work. And here we only present a preliminary result regarding the rotation period, color indices, taxonomy, and diameter. And based on the light curves we have initially analyzed, we can say that the rotation period is about 3 minutes. And in connection with the topic of the workshop, we would like to mark the usefulness of using small telescopes in observing fast rotating asteroid on the example of our first observation that object. When object was verified, average brightness was only 18.4 magnitude, and we used 0.7 meter telescope and only 5-second exposure time. And during 19 minutes of observation, we collect data from almost 30 rotations, which allow us to make a quite accurate composite light curve, like you can see here. And in the next part of the poster, we show how we determine the color indices by determining the shifts between light curves in G, R, I, and Z bands. And next, we compare our results with spectra of various taxonomic classes. And at the end, we calculate the diameter. I invite you to read the entire poster. Thank you for your attention.
Okay. Thank you, Paweł. Yes, all posters are put on the webpage of the workshop. You can see it and read the details. And thank you for presenting your results. And we see how difficult are the studies of NEOs and how interesting they are. Are there any questions to Paweł? Okay, if not, so let's go to the next poster. And next on the list on the web page is Władimir Trojański.
Yeah.
So,
now,
Władimir.
yes, I'm here.
Okay. Good, you can share the screen and.
Yeah. Now I try to.
Okay, we can see your poster.
Okay, maybe now I try to the full. Yeah, now it's better. So hello everyone. As said, editor, my name is Władimir Trojański, and today I have a very short presentation and I want to present some results what we get from last our campaign, observing campaign, the Jupiter Triton asteroids. So first, what I want to show, yes, you can see them on my slides and my co-authors, and say thanks to all people who joined to this campaign. Thanks for idea, for observation, for data reduction and processing, and of course, thanks for help with prepare the publication. How you can see different people from different countries and different places. And why Triton asteroid on Jupiter asteroids? It last year starting the NASA Lunar mission. How you can see the timeline on this page and trajectory for this mission, yes. And the main goal, what should do the Lucy, this is explore the Triton asteroids, 4 targets from L4 Lagrange point, and 1 target from L5 Lagrange point. So this is why we try this target and observe 2. So, and of course, least telescopes was observed as targets. Main part data we get from 2 Ukrainian telescopes what located on Terskol Observatory. After join 2 telescopes from Odessa, Ukraine, and Polish telescope what located in Arizona. 2 telescopes from Lowell. After Kitt Peak, Tide Observatory, 2.2 meter telescope from Hawaii, and when we finish, very close to finish our observation, plus for observatory who something observed to us too, from observatory from Nikolaev and Kiev from Kiev, and 1 night observation we have from Lishan Observatory in China. So how you can see, I marked the red color 3 telescopes, yes, what telescopes now included in European telescope network. So it's very nice data from these telescopes, what I can say. And very fast to our results for all 5 asteroids, we can determine the core index. For example, this is only for 2 targets. For some asteroids, we get a composite light curve. 2 asteroids have the very long rotation period, this 100 and 100 hours. So that's why we need more long time observe these targets. And plus for 3 targets, we can get the phase curve and how result determines the G1, G2 parameters, and compare with the result from another author, this Vasily Shevchenko and Tagmar Ashkevich. Yes, and you can see how this looks like with our results. So now we start to prepare the publication to a current journal, and I hope very soon we can publish all our results from this campaign and see on next campaign. So thanks for attention.
Thank you, Volodymyr, for your presentation. And this is another example of great work that have been done with large coordination of large number of telescopes all over the world. So it's very impressive work, very impressive coordination. Do we have any questions for Volodymyr?
Sorry, could you explain a little what does it mean, G1 and G2 parameters?
This is a function what we approximate the phase curve. So we can get the H absolute magnitude and G parameters, or absolute magnitude and parameters G1, G2, what approximates our observation, and after we can something say it about taxonomy. This is target.
Thank you.
Okay, do we have more questions? If not, let's go to the next speaker, which is Inna Izviekova. So Inna, if you are ready, please share your screen.
Hi, can you hear me?
Yes.
Yeah. Unfortunately, the connection may be interrupted since I'm currently in the margins in the observatory. So,
okay, we can see your screen.
okay, good. So I would like to tell you about the Tresco Observatory. It's this international observatory is located near Tresco, Kabardino-Balkarian Republic, Russia, height 3,150 meters, international code B18. There are two telescopes in operation, SAIS 2000 and SAIS 600. The two telescopes in operation, SAIS 2000 and SAIS 600. On SAIS 2000, in addition to photometry spectrum, are observed on a suspended multimode spectrograph. Magnitude 17 is available with resolution 200, with a resolution of 30,500. Magnitude 12 is available. Also in operation is a Maestro spectrograph, matrix HLS spectrograph, either 3-camera cross dispersed HLS spectrograph installed in the CUDA focus. The telescope SAIS 2000 with a resolution from 45,000. A polarimeter has also been used since 2019, boundary magnitude 14. SAIS 200 is mainly used for photometry. The diameter for the main mirror is 60 centimeters. Here's an example of the obtained images of comets on the SAIS 600. Comet Borisov has magnitude 19. For small bodies, we obtained photometry, astrometry, and spectra. Astrometry for near Earth and potentially dangerous. Photometry to determine their rotation periods of asteroids, to study the dust production of comets and centaurs. Spectral studies to determine the spectral classes of asteroids and their composition. We are ready for cooperation and open to applications. Applications can be submitted through the official website, or if you have any questions, you can contact the mail. The observation schedule is formatted 1 month before the end of the semester. Thank you for your attention.
Okay, I'm not sure if it's only my problem, but we have stopped on your third slide and we couldn't see anything more. So if you, so probably there is something with the sharing the screen. So if you could fastly go through the slides 4 or 5 and go on. Oh, now we see your last slide.
Okay, I don't know what is this problem.
Okay, anyway, thank you for your talk. Fortunately, we've got all posters included on our workshop webpage, and we've got your webpage on the screen, so we can go to the webpage of the workshop and read in detail your poster. And if there are any questions, they can be given now or after reading the posters. If someone will have more questions, for sure we'll contact you. Do we have any questions now? Okay, I don't see any questions. Thanks again for your talk and nice presentation. Oh, Grażyna, you have raised hand.
Yes, I believe that this is a very good telescope for observations, and we necessarily will use it. Thank you.
Yes,
Yes, it's a very impressive telescope from the pictures, and in the real it has to be even more impressive. Yeah, okay, so let's go to the next presentation, and next poster will be shown by Patrycja Poźniak from Poland, not Ukraine. Sorry for the mistake on the web page. So Patrycja, are you ready?
Yes, can you hear me?
Yes, we can hear you. Please share your screen.
Okay, just one moment. Okay, can you see it?
Yes, we can see, but it's very big. So we don't see all the whole poster. We can see part of it. So
Oh, it's actually not gonna be crucial to the presentation at all. So, I can make it smaller. Is that better? Hello?
Could you move up the screen? Okay, now it's better. We can see the upper half of the poster. So I'm not sure if we can see your mouse. Yes, we can see. So please mark with your mouse what you are, which part you are talking about, and we will see. Okay, so please, stage is yours.
Okay, thank you. So actually, what I am planning to do today, since this poster is like public, so anyone can read it, I'm just gonna focus on highlighting the advantages you're gonna get from doing basically the same thing I did, which is automatic calibration of photometric observation of asteroids or whatever you decide to observe. And the software we used for this purpose is called Photometry Pipeline, but I am aware of the fact that there's more software like that available. So we're actually gonna jump right here and try to highlight some advantages. One of them being the fact that it's actually very time efficient in more than one way, since for example, you don't have to spend long hours doing observations to provide useful data. For example, this phase curve, something like this phase curve can be achieved by doing one full cycle of asteroid and then maybe around an hour a day, a night of observations. So, and it's still useful, and it requires significantly less data than the composite curve. So it's good for people who just want to contribute to science but don't have a lot of time. And another way in which this is time efficient would be the fact that, as the name suggests, the photometry is automatic, calibration is automatic, which means you just run the software in the background. I used 15 minutes as an example for 80 frames, which is probably going to be different from you because you may use a different telescope. But the point is, you don't have to look at the screen for the 15 minutes or whatever the time is. You can just do whatever you want during that time. So it actually saves your time because we all are busy, right? And it is good to have the ability to do something in the meantime. Another advantage is that you don't actually need to have the filter that you need for observations. You can just calibrate it to any desired band, and this is because well, the reason why you may not have the filter may be financial reasons, or maybe the object you're observing is very faint, so you don't want to lose any photons, so it can be easily calibrated. Actually, most amateur-owned CCD cameras have front side illuminated CCD chips, which have quantum efficiency similar to Johnson-Cousin's R filter. So it's gonna be easy to calibrate, and the accuracy of that particular type of calibration is 0.01 magnitude, so quite good. And yeah, it can be very helpful for both professionals and amateurs. So I would recommend it, and I hope you will find it useful for your work. So thank you for your attention.
Thank you, Patricia, and thank you for presenting your work and giving hope that we can save our time, because nowadays not anyone have too much time. So if there is a tool that allows to save our times, we will be very happy. So thank you for your talk. And are there any questions? I don't see any questions, so let's go to the last poster, which will be shown by Alceste Bonanos. And Yuri Krugli was able to reconnect, so after the poster by Alceste, Yuri will give his talk at the end.
Okay, thank you everyone. Hello, thank you for staying till the end, almost. Let me try and connect here. It says disabled participant screen sharing. I don't know.
Can we give permission for sharing the screen?
Now I can, okay. Okay, I hope you can all see the screen. So I'll be presenting the 1.2 meter Grionetti telescope on behalf of the team at the National Observatory of Athens that's operating it. So it's an ideal facility for science requiring high cadence and multicolor observations. Just a few words about the telescope and the observatory. It was established in 1972. It's located in the northern Peloponnese in Greece at an altitude of 930 meters. Weather conditions are quite good. It has a 1.2 meter diameter mirror. In 2016, it was upgraded in the context of an ESA project and converted to prime focus with f2.8. It has an IAU minor planet center code L10, and we currently have 2 instruments on it, a fast frame twin camera system with CMOS and Drozila cameras, observing 30 frames per second in the RNI bands, and with a 17 by 14 arc-minute field of view, and also a simpler Aspen CCD camera with UBVRI Bessel filters and a 12 by 12 arc-minute field of view. So a few words about our research project. So we're mainly doing, the main project right now is lunar monitoring in Eliota. This is the ESA project that actually upgraded the telescope and equipped it with a fast frame cameras. On the right, you see an image of the moon, and all the dots show the locations of impact flashes that we have detected there. You can find more information about it on our website. We're trying to determine the size frequency distributions of meteoroids and small objects that are impacting the moon and creating flashes of light that last for a second, or actually less than a second. And that's why we need the fast frame cameras. But these cameras can be used for other projects requiring fast observations, such as transients and variable stars, as you see further down, also occultations. So it's very useful for asteroid and NEO science, astrometry of planetary objects you could do, and satellite tracking. So on the bottom left, you see 2 images again of a multi-frame lunar impact flash, an example. So we're looking at the non-illuminated side of the moon. The little red circle corresponds to the flash, the little light that we see, and the inset shows the brightness decrease over time. Okay, so moving on, just to show again some more examples. On the bottom left, let's start here with stellar occultation of Triton in 2017. So there were a lot of observatories that were on this. So Neptune's moon, and we observed it from Creoneri as well, although we were outside the path, but it was useful to have this constraint as well. Then we've used Creoneri has contributed to the light curve of a microlensing event, Gaia 16AYE. And this has been published. So some of the RNI band points were from Creoneri. And we also observed a satellite, so Bete Colombo, when it had its Earth flyby in April, and this was already published. So it's at the very center. So we're tracking on the satellite, and you have the stars being trailed. Okay, there's not much time for this presentation. There's more information in the poster, but we're in the telescope network, and we invite you to use our telescope for your high cadence multicolor observations. We've offered quite a few nights, since we're not currently operating 24/7. I mean, not 24/7, but we're not operating every single night yet. That's our goal. So we are open. We have quite some time available for other projects. So please contact us if you're interested. Thank you very much.
Thank you for your presentations and for presenting another nice telescopes. I'm really happy that we have so many places with so good equipment that we can use nowadays. So it's really fascinating that our capabilities are increasing still, and we can use so many different observing sites. Okay, so